Visual memory is the mental representation of an object or idea, and any properties of that object that may be relevant to recall. Some people find things easier to remember when there is a visual component related to the topic they are studying. We use our eyes to navigate the world around us, so it only makes sense that we would store some of this information in a visual format in our working memory and long-term memory. When an image is stored in our working memory, and eventually our long-term memory, certain details about the image are also saved so that it makes it easier for us to recall that image, or the concept of that image, later on. Visual memory is flexible. By using it regularly, a person can strengthen their ability to recall images at a later point in time. Visual memory is another tool which we can employ to help our working memory store ideas more efficiently in the long-term memory. When we talk about visual memory, we are not only referring to specific things that we have seen and can reproduce in our minds, but instead we can also refer to propositions, which are abstract ideas that bring forth a particular idea. For example, imagine a tasty apple. You are likely picturing a fruit that you've never seen, nor will you ever see, but you can still create a picture of it in your mind. This proposition is based on a series of features that you know represent a tasty apple, such as a crisp, unbroken, and perhaps even shiny skin. In your mind, you associate these features not just with an apple, but with the characteristics of a tasty apple. That raises the question of how accurate our visual memory is and how much information about a particular stimulus is stored in the working or long-term memory. In our apple example, we have stored particular ideas about what an apple should look like, but no particular images. Conversely, if asked to imagine a loved one's face, the particular details may be much more well known. Generally, the more details that can be recalled about an image, the better it is stored in your long-term memory. However, if there are issues during the retrieval from long-term memory, it can cause distortion, causing inconsistencies in our visual memory and what we are able to accurately recall. When we dream, our brain uses propositions which we have learned to create new ideas and give them life. By doing this, our dreams can become incredibly vivid and lifelike. While we may have never encountered that particular situation or people before, but they are constructed off of previous propositions that we have created over time. Propositions are stored in the long-term memory the same way that any other category is. It relies on a series of keywords to describe the proposition so that when it comes to retrieval, the working memory can quickly determine if the proposition is worth recalling. One point of contention in the science community is how visual memory is used by the working and long-term memory, or more importantly, how they differ in what they do with the information given to them by the visual memory. One of the popular theories is the dual code theory. It proposes that a long-term memory stores information either as a verbal or imaginal system. The verbal system stores info in a text form, while the other system stores information as a series of images. It makes sense to see that these two systems are interchangeable, and it is possible to swap between systems. Studies that support the dual code theory show that people use both of these systems regularly. While both systems are used to recall concrete information, the verbal system is the only one used for abstract concepts. Another theory is the unitary theory, which suggests that long-term memory only uses verbal-based encoding, with all images consisting of only a series of propositions. During recall, the working memory takes those propositions and forms an image. If the image has gaps, the working memory fills in the gaps with what seems to make the most sense based on the prior experience of the thinker. One benefit of using visual memory as a learning technique is that people are more likely to pick up concrete objects more than they are abstract ideas. Having something that they can see solidifies the idea into something tangible, rather than keeping it in a verbal or text form. Particularly with younger children, using visuals in a lesson will dramatically help students remember and recall information. Using visuals also helps young students quickly identify similarities between objects, helping them develop internal categorization. While visuals are more engaging and can help students better understand concepts, they are best used in conjunction with text so that the students can experience this information in both forms. An example of what this looks like in a social studies class is a map of a battle. Being able to visualize where troops are and how they move can help students understand how the battle progressed and why one side had an advantage over the other. In science, a dissection map could help students have a visual idea of what they might expect to see before they begin their dissection. In math, a diagram can help students visualize a problem instead of having to come up with their own visualization in their heads, which may overtax their working memory. Visual memory is a strong tool to be used in conjunction with more traditional text-based and verbal instruction. Images are encoded in the form of propositions or key details that describe an image. There is debate over how visuals are stored in the brain through the dual code theory or the unitary theory. And using visuals in the classroom can help reinforce topics and give students a better understanding